That answer was generated on my laptop by a free local model from documents I gave it with the source file named. The documents are this channel's own episode transcripts, so I can verify every word it said. The entire system behind it is about 40 lines of plain Python. No framework, no cloud, no magic. Today, we build it, step by step, and I will also show you the one place where even this grounded, cited answer quietly lied. By the end, you will have built RAG with your bare hands and know exactly where it breaks. Quick note before we dig in. If you find this useful, subscribe and drop a topic you want explained in the comments. Now, let us get into it. Last episode we covered what RAG is and why it beats fine-tuning for facts. Here is the reassuring secret that makes building it approachable. Every RAG system on Earth, from a weekend hack to one serving millions, is the same two pipelines. One runs ahead of time once to prepare your library. The other fires every time a question arrives. Index, then retrieve. Let us walk them with real code. Phase 1 is indexing, and it happens offline, before any user shows up. Step 1. Load your sources into plain text. Mine are 3 transcript files in a folder called corpus. Step 2. Chunk them, because you should not shove whole documents at a model. A chunk is a bite-sized passage, and the simplest honest rule is 1 paragraph, 1 chunk, 10 lines. Read every file, split on blank lines, remember which document each piece came from. Why the overlap-free paragraph split? Because a paragraph is usually one complete thought, and one thought per chunk is what you want retrieval to grab. Now here's the real run, captured exactly as it happened. 12 chunks from 3 documents, and you can see chunk 7 is a clean, self-contained passage about cosine similarity. I will flag now that chunking is genuinely make or break at scale, and it gets its own episode soon. Step 3. Embed. Each chunk goes through an embedding model, the exact tool from episode 3, and comes back as a vector, a list of numbers capturing its meaning. Look at the real output in that capture. 12 chunks became 12 vectors of 768 numbers each, and you can see the actual first 5 numbers of the first one. Meaning, as coordinates sitting in memory. Step 4 is store. At our size, a Python list is the store. At real size, this is what vector databases are for, and that is the next episode. Your library is now indexed. You never run this phase again until the documents change. Phase 2 runs live on every question, and it mirrors the question's journey. Embed the question with the same model as the chunks, so both live in the same space of meaning. Search for the nearest chunks. Build the prompt. Generate. Read it top to bottom, because this file is the whole idea of RAG. The cosine function measures the angle between 2 vectors, straight from episode 3, written out in 4 lines so nothing is hidden. The question gets embedded, every chunk gets ranked by similarity, and the top 3 win. Then look at the augment step, because this is the A in RAG, and it is just careful prompt building. An instruction that says answer only from the context and cite the source. Then the retrieved chunks, each labeled with its file name. Then the question. The model reads that assembled prompt and writes the answer you saw at the top, grounded in passages I can check. Now scroll back to that opening answer one more time, because I promised you a lie. The answer itself is correct and grounded. But look at the citation link the model attached. That GitHub URL does not exist. Nothing in my prompt asked for a link. The model decorated its citation with a plausible-looking URL purely out of habit in the middle of an otherwise honest, grounded answer. Captured live, unedited. That is the deepest lesson in this entire episode. RAG constrains the model with real context, and the model still fills every gap with plausibility. The retrieval you build controls what it knows. It never controls what it embellishes. Grounding narrows the space for hallucination. Verification closes it. So where do frameworks fit? Tools like LangChain and Llama Index hand you industrial versions of every step you just built by hand. Loaders for 50 file formats, smarter splitters, connectors to every embedding model and vector database, retrieval chains that wire the flow together. Use them, they are excellent. But use them the way you now can, knowing exactly which of the 8 steps each piece replaces. The engineers who debug RAG systems well are the ones who can point to the exact step, chunking, retrieval, or prompt, where the answer went wrong. Here's how to use this today. Clone the lesson from the repo below, drop your own notes, docs, or reports into the corpus folder, and run ask.py with your own question. Everything runs locally with a llama, so nothing leaves your machine. And if you want the full application version with a proper vector store and a chat loop, that is exactly what we build end-to-end in the episode 48 build-along. What you learned today: RAG is an offline index pipeline, load, chunk, embed, store, plus a live pipeline, embed, retrieve, augment, generate. You built both in 40 honest lines. You watched real vectors and a real cited answer come back, and you caught a grounded model inventing a URL anyway, which is why retrieval quality and verification decide everything. We stored 12 vectors in a list and got away with it. At 1,000,000 vectors, you cannot loop and compare. Finding the nearest neighbors fast, at scale, is an entire engineering discipline with its own products. Next episode, vector databases and similarity search. That is the core of it. If this helped, hit like and subscribe, ring the bell for the next deep dive, and tell me in the comments what you want broken down next. Thanks for watching.